We're going to take a quick look at some basic vector problems, and we are only going to be dealing with problems that are either make straight angles or that make right angles. So a straight angle is essentially when they would land into a straight line. So our first example here says we have a velocity of 150 meters per second north and a second vector of, so for the first one here, we're going to go 45 meters per second to the south. So if we represent our first vector here as 150 meters per second going north, we're going to use upward as our north direction. Then we can represent our second vector at 45 meters per second going south. Since these would be straight in line with each other, they would be considered straight angles. And in this situation, because they are going in opposite directions of each other, they are going to work against each other. So in a situation like this, to find our resultant, we would take our 150 minus our 45 because they are going in opposite directions, and that would leave us with 105 meters per second. And in this case, it is going to be going north because that was the vector that had the larger magnitude out of the two that we were working with. So our resultant for this question would be 105 meters per second going north. Now on our second one here, we are still going to be keeping our 150 meters per second going north, but now our second vector is going to be 45 meters per second, also going north. So these are going to be in the same direction as each other, which means they are going to work together. So to find our resultant for this situation, because they are in the same direction, we would actually add them together to get our resultant of 195 meters per second, and we would be going north in this situation. So both of these represent straight angles because they lined up with each other essentially at 180 degrees to make a straight line on each of these. Now our next ones that we're going to look at are not going to be at straight angles. We are going to work only with ones that are at right angles. So this time we still have our velocity of 150 meters per second going north, and our second vector is 45 meters per second going east. Okay, so we would have a right angle right here. Now I'm going to look at two different methods to solve this type of problem. The first way we're going to look at it is what's known as the parallelogram method. And with our parallelogram method, what we do is we extend our vectors so that they make a nice parallelogram. And then our resultant will go from the vertex where our vectors are intersecting to this point right here where our extended vectors would intersect. And this is going to be the value of our resultant. Now, because of some theorems in geometry, when we have a parallelogram, opposite sides are equal. So this 150 value, I can transpose over to the opposite side here. Same thing with this 45, I could transpose that up to the opposite side there. Now what we're going to focus on is the shape right here, which will end up being a right triangle. And that's going to allow us to use the Pythagorean theorem. So my Pythagorean theorem says if I take my legs squared plus my legs squared, that's going to be equal to my hypotenuse squared, which is my resultant in this case. Now in order to solve this out, I need just the resultant. I don't want the resultant squared, so I would have to square root both sides. So I end up needing to find the square root of 150 squared plus 45 squared. Okay, when you type that into your calculator, you get 156.6, and the decimal keeps on going. Now we have two sig figs in this problem, so we would actually write our answer as 160 meters per second is equal to our resultant. Now in more advanced classes, you would then go on to find the angle, but all we are doing right now is we are finding the magnitude of the resultant. So our resultant, if we were to combine these two vectors, would be 156.6, but we have two significant figures, so we would put that in as 160 meters per second. Now the triangle method is very similar. I'm still going to start with my 150 meters per second going north, but now my second vector, this 45 meters per second going east, I am going to start that at the head of my 150, and I'm going to put it going east here. So this is where we sometimes call this head to tail addition. And once I get that done, then I can go ahead and sketch my resultant in here. And now notice I'm still going to have a right triangle, and I'm still going to use my Pythagorean theorem, where I would say my resultant squared is equal to 150 squared plus 45 squared. Follow the exact same process we did when we did the parallelogram method, and we will get the exact same value. So whether you use the parallelogram method or the triangle method is entirely up to you. You have to just think about which one is going to make most sense for you. Okay, now our next problem. Same 150 meters per second going north, but this time my second vector is 45 going west. So if I do it using the parallelogram method, I'm going to extend both of my branches here, and then my resultant is from the vertex where my vectors are joined to this location over here, and then I can transpose all of my information. And notice again I have another right triangle, so my resultant squared is again going to be equal to 150 squared plus 45 squared. I would square root both sides, and because I didn't change any of my numbers, my resultant is still going to be equal to 160 meters per second for this case. But now notice the direction would be different. If we were to go ahead and find the direction and explain that in terms of angles, our direction would be very different from what we had on our last slide. You can do this same problem using the triangle method. So I could start with my 150 and then do head to tail addition for my 45 and find my resultant there. And again, it's going to lead me right back to that exact same equation. Now, sometimes you will see this formula used where it says r is equal to the square root of x squared plus y squared. This is just a version of the distance formula, which is from the Pythagorean theorem that we just did in the last two problems. It comes from the fact that whether you're using the parallelogram method or the triangle method, you end up with a nice right triangle. Okay? And typically we call our right and left distance our x, our up and down distance our y. So when we apply the Pythagorean theorem to this, we would have r squared equals x squared plus y squared, just like we did on those last two examples. When we square root both sides, we end up with r is equal to the square root of x squared plus y squared. So that's where this formula comes from. But now keep in mind, this is a very basic formula. Once you start to get into some more advanced vectors and things like that, we would have to do slight modifications to consider, well, what happens when they are not at 90-degree angles to each other.